All right, so the length of time to prepare Thanksgiving dinner is analyzed. In a sample of 36 meals, the average time to prepare was 195. Sigma is equal to 25. Use a .01 level of significance to test the claim that the actual time to make dinner is less than 220 minutes. So this is talking about the average time, yes? That's what problem number one is dealing with. It is dealing with the average time. What you need to look for when you're dealing with averages, whether it's confidence intervals or hypothesis tests, what you need to look for is n greater than 30 and do I see sigma? Those two things. All right? Usually, they in my class, they go together. Okay? In the book, it really comes down to sigma, but in my class, I put them together. All right? So the fact that you see sigma is going to imply that n is bigger than 36 or 30. It's 36, so that works good. All right, so part A, it will ask you for part A. That is for you to define HO and H1. In this case, HO will be that mu is equal to 220, and H1 will be that mu is less than 220. Okay, this is my claim here. All right, part B, we got to go to the picture. This area here is what? 0.05? 0.01. 0.01. If you look up 0.01 on the z-score chart, that's negative 2.33. You'll notice I put a negative there because it's on the left-hand side. If we're on the right-hand side, I put a positive 2.33. All right. Part C. Yes?
So why didn't you go to the T chart?
I go to the T chart if n is less than 30. I go to the Z chart if n is greater than 30. What is n?
36.
So which one is that? That's the Z. I mean, it's a very good question because it's confusing. At best, it's confusing. Okay. Okay. All right, part C. Z equals x bar minus mu over sigma divided by the square root of n. Okay. Let me remind you that if you are to get the formulas on the test, you just get the formulas. You don't get any words. There's no discussion of which ones are which. And I can tell you from previous experience, I took a class, it was called Thermodynamics at University of Florida with Dr. Gator. The dude's name is Dr. Gator, and he's a professor at the University of Florida. And he freaking wrote the book that we were using. Like, when you looked at the front cover, it said Dr. Gator, University of Florida. Okay? Course was hard as hell. And he made it better sounding by saying, I'll give y'all all the formulas you need for the test. You don't have to memorize any of them. Man, I went there like, oh, hell yeah. He's giving us the formulas. This shit could be easy as hell. Man, I read the question, I'm looking at that formula sheet going, all right, it's one of them. There's 15 of them. And that's what happens on the test. Like, people go like this. All right, has an X bar in it. And then you look at the sheet and 4 of them have X bar and you're like, ah, crap. Okay, so do keep that in mind, that getting the formula only helps if you know which formulas go with which problems. Okay, so part D, and I'm just going to do this D up here so I don't scroll down too much. It's Z equals X bar, which is 195, minus 220, divided by 25 over the square root of 36. Do we agree? All right. You guys are going to get the full explanation today. All right. So now to type this in, open parentheses 195 minus 220 divide by open parenthesis 25 divided by square root of 36. Okay. You get negative 6. Does everybody see that? I don't know why I cannot take a screenshot. It drives me insane. But anyway, just envision this being captured over here.
You can do it on your keyboard. Press like control
No.
or screen.
No. Don't want to. Make me mad. I can also do it like this, but I mean, that's a pain in the ass. Well, maybe I can't. Shit. Oh, yeah, look at me. Watch this. Bam. You just need to hide that. Look at that. Okay. Now, if this is negative 6, where does negative 6 fall on this graph? It falls here, yes? Negative 6 is well to the left of negative 2.33, right? So do you reject or fail to reject HO? You reject HO. All right. All right. Now, if I reject HO, I'm saying that this is false and this is true, yes? So what is that doing to the claim? It's supporting the claim, right? So I'm going to scroll down. We're going to put F right here at a 0.01 level of significance. It says significance. There is sufficient evidence to support the claim that mu is less than 220. Does that make sense? Here, G, just kidding. Since n is greater than 30, the sample mean is normally distributed. Okay. All right. Questions on number 1? At a 0.01 level of significance, there is sufficient evidence to support the claim that mu is less than 220. Okay?
So how do we know when to use this formula and when to use the x bar minus e's?
Good question. And let's,
Because that's where I originally started.
okay. You see how the number 2, it says construct a confidence interval? That's the x bar minus e stuff. When you're doing a confidence interval, that's the x bar minus e is less than mu, which is less than x bar plus e.
And then we have the level of significance.
And there, this is a 95% confidence interval. The other one's a level of significance, like 0.05 or 0.01. Yes, sir. Okay. I apologize for those of you watching at home. The question that was asked was, can I go back to G, number 1? That's not the question I'm referring to, though. Number 2, the other question that was asked was, how do you know the difference between a problem that requires me to do this versus a problem that requires me to, do x bar minus e is less than mu, which is less than x bar plus e? Right, that's the other formula we're referring to. This is for a confidence interval, okay? And the problem will say construct a confidence interval. Does that make sense? Like it'll say that. Okay. All right, going on to number 2, trying to estimate the cost of Thanksgiving dinner. You know they actually do this every single year. This year the cost is actually down like 40 cents from what it was last year, and they're estimating that to feed 10 people with leftovers, the cost of Thanksgiving dinner is $49.10. I don't know what the hell Walmart they shopping at. I don't know, Spam maybe. They have Roman noodles and a jam sandwich. They just taking 2 pieces of bread and jamming them together. Trying to estimate the cost of Thanksgiving dinner. Researchers asked 25 people. The average is 25 people is $49.50. S is $3.75. Use this to find a 95% confidence interval. Now this is the one doing a confidence interval. So now the question is, do I use the z-score or the t-score? Okay, we know we're dealing with the mean. Do I use a z-score or a t-score? What are you looking for? If n is greater than 30, well, what's n?
25.
So what does that mean?
So you use a z-score?
You use a t-score.
I got them switched, Dryer.
I know, and you were doing so good.
What?
All right, so we're using the t-score for number 2. Because n's less than 30 and sigma's not known, we know s. Sigma's not known, we know s, and n is less than 30. That is going to be a classic t-score problem. Now, in order to do the t-score, we got to know degrees of freedom. Remember that degrees of freedom is always n minus 1. So for part A, we're doing this area here is 0.95. Makes this area here 0.025. Now when I look this up, I got to use the t-score chart that has degrees of freedom down the left side. Across the top there's 2 pieces. Remember, we're not doing the area in 2 tail. We're only doing the area in 1 tail. That says 1. All right. And so we're going down to 0.025. 0.025 in 1 tail. Find that column. And go down to degrees of freedom 24, right? Because degrees of freedom is always n minus 1 for this course. Okay, so going to 24, 0.025 in 1 tail, what do you get? 2.064. So this is 2.064 and this is negative 2.064. Part B. X bar minus E is less than mu, which is less than X bar plus E, where E is equal to T times S over the square root of N. Part C, it's 49.5 minus 2.064 times 3.75 over the square root of 25. Which is 49.50 plus 2.064 times 3.75 over the square root of 25. Now, I'm going to go ahead and type that into the calculator for you. $49.5 minus 2.064 times 3.75 divided by the square root of 25. The left side is 47.952. Doing the right side, it's the same thing. Second, enter. Change the minus sign to a plus. 51.048. Just a reminder that you can check that value by going to stat, test, going down to T interval, which is option 8, putting it on stats, press enter if you have to, and typing in the numbers as you see them. 49.5, 3.75, 25, 95, calculate. There you go. Okay. All right. How do we interpret? Oh, wait, hold on. I'm sorry. You okay?
Yeah, I'm okay. I'm gonna take one of these, okay?
Yeah. Oh,
See you tomorrow, Jordan.
love you, baby. Take care. Oh, it's on video. It's not my wife. It's just a student, but I love her. She's so nice to me. Lord knows I have people damn complaining. He doesn't love me. Yes, I do. Don't tell your mother. All right. I really wanted to show how you do both of those. Although this one probably ain't helping a whole shit ton. Sorry, stuff ton. Just cost me another quarter.
Every time it's played, right?
Huh?
I said every time the video plays, right?
No. No. I think I lost about $13 yesterday. All right. New day today, though. I'm on my diet again, too. Well, after lunch, I'm starting it again.
Shake.
That was yesterday. All right.
Once a year thing, or
Huh?
a once a year thing?
Oh, no, it's definitely daily. Just not today, because I got to go to the doctor tomorrow, and I need to be down 20 pounds. All right. For real, they called me the other day, and I was like, oh, shucks, I should have stayed on my diet. Why did I get off? Oh, I know why. Because some student told me that the peppermint shakes were back. And I damn sure went that night, and you were right. They are back. And they are just as good as I remember in them. If we continue to take samples of size, we'll be on 25. We expect 95% of the sample means to be between 47.952 and 51.048. Party population is normally distributed, and sigma is unknown. Okay. All right.
So we really have no justification for the population is normally distributed, just that it has to be for us to be able to do the work.
That part. Yeah, no, we're not providing any justification. We're just it's an assumption.
Okay, yeah, I see that on the top here.
All right. I ain't even lying. I won't be one of the other 13. I'll be part of the 57. Brooke and I will be. All right. Hey, Brooke, you overeat on Thanksgiving or not really?
What?
Do you overeat at Thanksgiving or not really?
Well, I always eat a lot. Like I can eat.
They say if you eat so much that you want to take a nap afterwards, you ate too much.
Then I overeat.
He said I overeat every meal. All right. So we're going to test the claim that 65% of the people will overeat. So A is HO is P is equal to 0.65. 0.65. H1 is that P is more than 65. Do we agree? Part B, this is a right tail test, yes. For proportions, we have to use the z-score, so that's 1.645. Yes. Part C, you got to know the formula. Z equals P hat minus P over P cube over N. Okay. I don't know what P hat is, but I do know that this knows. So 57 divided by 80. 70. Potato, potato. All right. So P hat is 0.81. Can we agree? So the formula will be Z equals 0.81 minus 0.65 divided by square root 0.65 times 0.35 divided by 70. Remember the square root's got to cover the whole thing. Okay. How did I get 35%? It's 1 minus 65%. Okay. It's the opposite percentage. We call it the complement in statistics. So open parenthesis 0.81 minus 0.65 divide square root. Here it's 0.65 times. Use the time symbol, please. Don't use parentheses down there. 0.35 divide 70. I know some of your calculators are a little bit different than that, and this cursor sits up underneath the square root. You type it all in at once. Just type it in the way you see it. 0.65 times 0.35 divided by 70. Hit enter. You get 2.81. Okay. I don't know where to move that to. We'll just put it right here. Okay. Now, if that's 2.81, do we reject or fail to reject HO? We reject HO, so I'll do E right here. So E will be reject HO. If you reject HO, what are you doing to the claim? At a 0.05 level of significance. There is sufficient evidence to support the claim that P is greater than 0.65. Part G, since N times P and N times Q greater than or equal to 5, the sample proportion is normally distributed. Any questions on that?
What do you go to? You go to stat and Z-score
For what?
numbers to make sure you're right.
For that, there is none.
Okay.
We don't do anything for that. There is a way to do it. I don't know how to do it though. So you'd have to ask Alexa or Google it.
I wasn't here, but how do I know if there's a right tail or left tail?
Great question. How do you know whether it's right tail or left tail? This sign here will tell you. If it's greater than, it's on the right side. If it's less than, it's on the left side. All right. All right. Got 20 minutes. We got 2 more left. I think we're doing good. Any other questions?
Can you scroll down so I can see? Yeah.
Okay. Hannah, we good? I just wanted to say your name on the internet.
Number 4, is it, what's the difference between 25 students and 49 students?
I thought we weren't using the numbers.
It was supposed to be 49.
49.
Yeah.
Instead of 25?
Yeah, it's supposed to be 49. I changed it without changing it.
Yeah, so it worked well. Still the equation for 3 on this formula thing.
Say what?
Oh shit! I gotta change it a lot. Give me 1 second. I'm gonna pause this. That just cost me another quarter. You good? Part A. Part A. We're doing a confidence interval for the mean. So this is 95%, makes this 0.025. Bless me. Thank you. Because this is because n is 49, we know sigma. This is going to be a z-score, so when we look that up on the z-score chart, it's 1.96. Hopefully you've memorized that by now. If you haven't, there's still time. Part B, x bar minus e is less than mu, which is less than x bar plus e, where e is equal to z times sigma over the square root of n. Part C, Part C, what are the numbers? 62.84 minus 1.96 times 12.5 over the square root of 49 is less than mu, which is less than 62.84 plus 1.96 times 12.5 over the square root of 49. Okay. Let's type those in. We'll get the answers. Here they go. All right. So 62.84 minus 1.96 times 12.5 divided by the square root of 49. I know that that's the 7, but for those of you that don't, square root of 49. 59.34 is one side. I'm doing it again. Changing the minus to a plus. So we get, let's copy that thing. So we get 59.34 and 66.34. Huh, that's crazy. All right. Part D. If we continue to take samples size 49. We expect 95% of the sample means to be between what did I say it was? 59.34 and part E, since n is greater than 30, the sample mean is normally distributed. Fair enough? I apologize for how long the video is, but this covers all 5 problems of what you're responsible for test 4 for right now. Okay, future classes, sorry about your luck. We may have more, just depends. Gators won this week. Number 5, last one. The length of time to prepare Thanksgiving dinner is analyzed. Sample of 17 meals. The average time to prepare was 195. S is equal to 25. Use a .01 level of significance to test the claim that the actual time to make dinner is less than 240 minutes. That is 4 hours for those of you that are wondering. Okay. All right. Part A, HO and H1. I apologize. Let me pause this, number 5. I do want to go back to this and show you on the calculator stat, test, Z interval. Make sure you're on stats. And sigma is equal to 12.5. X bar is equal to 62.84. N is 49. And you'll see that we get to 59.34 and 66.34. Does that make sense? I just wanted to show you that's how you do that. Okay. We'll now rejoin your regularly scheduled program. Part A, HO and H1. What is the claim? That it takes what? Less than 240, yes? So the claim is that mu is less than 240. Is that HO or H1? So mu is less than 240. Mu is equal to 240. Part B, is this left tail, right tail, two tail? It's less than, yes? Now, at that point, excuse me, something. Oh, this is a T-score. We got to know degrees of freedom. Degrees of freedom is what? N minus 1. So in this case, it is 16. Going over to 0.01 under one tail, what do you get? 2.583. It is Kelly, but yes, thank you. Thank you. Brett shook his head yes, too. And that really made me think a little bit that it might be right. See, I'm giving you props, Brett. Huh? All right. But then I didn't know if you're one of those people in the preacher that's just talking and you're like, amen, and no matter what he says, you wake up, amen. Some of y'all go like this. That don't happen in my church. Well, you're going to the wrong one. All right. Formula T equals X bar minus mu over S divided by the square root of N. Princess, don't do that to me. Part D. What's X bar? 195. minus 240 over 25 divided by square root of 17. This is t equals, yes? Is it bad that I'm just hoping this is failed to reject? Because if it's not, I did a really, really bad job writing these questions. Please, 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 please. I'm saying please. There's still hope. Please, 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 please. Not only is there no hope, that's a solid rejection region, right? Like negative 2.6, you'd be like, let's do it again. Negative 7, it's like the Florida recount. That's like so far off, you're like, well, screw it, it's over. All right, well, negative 7.42. Hey, watch this, y'all. See, now that picture's not as big. All right. So it's equal to negative 7.42. Reject and fail to reject HO. Part F at a 0.01 level of significance. There is sufficient evidence to support the claim that mu is less than 240. What is G? Population is normally distributed, and sigma is unknown. Okay.
So if it was failed to reject, it would be positive?
No, if it was failed to reject, it would just not be more than negative 2.5, or less than negative 2.5 in this case, actually. So it'd be like negative 2 or negative 1.6 or negative 0.43. Any of those numbers that are not in the shaded area, you'd fail to reject. All right. Give me 1 second, please. I'm going to stop the video here. This portion of the video is brought to you by Chick-fil-A. Go have it your way.